integral 0 to pi by 4 x tan x into tan of pi by 4 minus x dx. This is the problem. Let me call this I. Firstly, let us make use of the formula integral 0 to a f of x dx is integral 0 to f of a minus x dx. So that this is integral 0 to pi by 4 minus x into tan pi by 4 minus x into tan x dx. This is I and this is also I. Now add I plus I. What happens? X tan x, no, tan x into tan pi by 4 minus x, tan x into tan pi by 4 minus x. If you get it a common factor, x plus pi by 4 minus x is nothing but pi by 4, isn't it? Pi by 4 into tan x into tan pi by 4 minus x dx, isn't it? Therefore, 2i is equal to pi by 4 into integral 0 to pi by 4 tan x into pi by 4 tan x into, what is tan pi by 4 minus x? 1 minus tan x by 1 plus tan x dx. My dear friend, you please observe, the problem is full of tan x, tan x, tan x. Let us change the variable. Let tan x is equal to t. What happens? Secant square x dx is equal to dt. That is 1 plus tan square x dx is dt, or dx is equal to dt by 1 plus t square. Moreover, limits will also be changed. If x is 0, t is 0. If x is pi by 4, if x is 0, t is 0. If x is pi by 4, t is tan pi by 4 is 1. Keeping these points in view, what is the answer for I? I is therefore equal to, come on friend, this is 2i is equal to pi by 4 into. You send to this side, what happens? I is equal to pi by 8 into, instead of integral 0 to pi by 4, instead of integral 0 to pi by 4, what are the limits that you have to take? 0 to 1. Integral 0 to 1, come on, tan x, it is t. 1 minus tan x, 1 minus t by 1 plus t. What is dx? dt by 1 plus t square. dt by 1 plus t square. This is equal to pi by 8 into integral 0 to 1 t minus t square by t plus 1 into t square plus 1 dt. Am I correct? Now this is the right time to use your ideas. As actually speaking, a suitable step regarding partial fractions is to be used. If you proceed systematically and according to the concept and subject, that becomes so bulkier. So you do one thing. This is equal to pi by 8 into integral 0 to 1 t plus 1 minus t square plus 1 by t plus 1 into t square plus 1 dt. Am I correct? Answer is before our eyes. It is visible. T plus 1 by denominator is 1 by t square plus 1. T square plus 1 by denominator is 1 by t plus 1. Both the integrals are known. Of course, between the limits 0 and 1, it is not impossible to get it. It's quite possible and it's very easy also to get it. Let us now do the same. That is equal to pi by 8 into integral 0 to 1 by t square plus 1 minus 1 by t plus 1 dt. That is equal to pi by 8 into, this is tan inverse t and that is log mod t plus 1 between the limits 0 and 1. Well, if you put 1, what happens? Pi by 8 into tan inverse 1 is pi by 4 minus log 2. Tan inverse 0 is 0. 0 plus 1 is log 1 is 0. Finished. That is the answer. So it is pi by 8 into pi by 4 minus log 2 becomes the answer. Let us look at the next problem, a beautiful problem. Something is new here. Dx by x tan x plus 1 whole square. Let me call this I. So what is I? I is equal to integral 0 to pi cos square x by x sin x plus cos x whole square. Am I correct? How could this step be obtained? By multiplying with cos square x on both numerator and denominator. Or otherwise, you take tan x as sin x by cos x and you take the LCM x sin x plus cos x by cos x whole square. This cos square x goes to the numerator and becomes like this. Whatever you call, whatever you do, that is the ultimate step. And now this is an interesting case to split this integral as look at that integral 0 to pi cos x by x into x cos x by x sin x plus cos x dx. Yes. This is of course the key step required. It's very, very important to observe. Moreover, at this juncture, we observe this 0 to pi cos x by x into d of minus 1 by x sin x plus cos x. Can easily follow it. What is the derivative of this? 1 by x sin x plus cos x whole square into cos x plus, see, UV formula, u derivative into v cos x, 1 into sin x plus x cos x minus cos x. Cos x going away, x cos x by, you will be able to have. That is, this particular expression is the derivative of this. Now you use integration by parts. By using integration by parts, this is equal to cos x by x into integral of this, that is minus 1 by x sin x plus cos x minus integral of f dash x, that is derivative of cos x by x, come on, minus sin x into x, that is minus x sin x plus v dash u, that is cos x by x square into minus 1 by x sin x plus cos x dx. Minus of this, minus of this. So this entirely will be cancelled, isn't it? Well, so minus 1 by x is one more thing. This entirely between the limit 0 to pi. Minus x sin x minus cos x minus x sin x minus x minus cos x, these two will be cancelled, so that it is minus 1 by x square is only remained. What is the integral of minus 1 by x square? Plus 1 by x. So this is equal to minus cos x by x into x sin x plus cos x plus 1 by x between the limits 0 to pi. 0 to pi. The next problem before us is integral 0 to pi by 4 dx by x tan x plus 1 whole square. dx by x tan x plus 1 whole square. Look here, let me call this I. This is equal to integral 0 to pi by 4. I am multiplying both numerator and denominator with cos square x. What happens? This is x sin x plus cos x whole square, isn't it? You can explain this step in two different ways. In one way, I am multiplying with cos square x on both numerator and denominator, or in another way, you can think of tan x as sin x by cos x. X sin x by cos x plus 1. As cos x is the LCM, x sin x plus cos x becomes the numerator, and the cos square x, if it comes to the numerator, it becomes cos square x dx. Like that you can have. Okay, cos square x dx. Now, the very crucial step here involved in the solution is this. Observe it carefully. I am writing this cos square x as cos x by x into x cos x by x sin x plus cos x whole square. This is the crucial step here to observe. Okay, this is equal to integral 0 to pi by 4 cos x by x into the particularity of this expression is just nothing but it is the derivative of minus 1 by x sin x plus cos x. You can easily observe that. Come on. What is its derivative? You take this as x, minus 1 by x, its derivative is 1 by x square, into derivative of this 1 into sin x plus x cos x minus sin x. Sin x and sin x will go away, leaving you x cos x. That's all. So the derivative of this expression is just nothing but x cos x by etc. Now I like to use integration by parts, taking this as f of x and this as g of x. Come on. This is equal to cos x by x into minus 1 by x sin x plus cos x minus integral of f dash x cos x by x. Come on, UIV formula you can make use of. U dash v, that is minus x sin x minus v dash u, that is cos x by v square, into integral of this is minus 1 by x sin x plus cos x between the limits 0 to pi by 4. Altogether this is minus cos x by x into x sin x plus cos x minus integral of x sin x plus cos x, x sin x plus cos x, they go away, leaving you 1 by x square dx between the limits 0 to pi by 4. Isn't it? If you get minus out, minus, the product is minus of x sin x plus cos x and x sin x plus cos x go away, leaving you 1 by x square. Again, integral of 1 by x square is minus 1 by x. So, this is minus cos x by x into x sin x plus cos x plus 1 by x between the limits 0 to pi by 4. We are coming to an end to conclude the answer. We have almost reached the climax step. Well, we can still simplify the expression involved in the bracket. Now, inside the bracket, let me take x into x sin x plus cos x as LCM. In the beginning minus cos x, and next plus x sin x plus cos x 0 to pi by 4. So x sin x by x into x sin x plus cos x is remained. Again divide with x cos x on both numerator and denominator. What happens? I am dividing with x cos x. Denominator becomes tan x by x sin x by cos x is x tan x plus 1 between the limit 0 to pi by 4, isn't it? X will automatically will be cancelled, no problem. I am dividing with cos x, you imagine. Sin x by cos x is tan x sin x by cos x is x tan x, cos x by cos x is 1. Okay, now you substitute pi by 4 first of all. Tan pi by 4 is 1. Pi by 4 into tan pi by 4 is pi by 4 plus 1 minus. If you take 0, tan 0 is 0, 0 plus 1 is 0, 0 by 1 is 0, so it is 0. You multiply 4 on both numerator and denominator so that you will be having 4 by pi plus 4 is the right answer. 4 by pi plus 4 is the right answer. It's a very good problem involving a beautiful step of dividing that numerator cos square x as cos x by x into x cos x. Yes. The second step previously we could have explained for ourselves. That is a crucial step and that is a special idea involved in the solution of this problem. You please have a note of that. This is the problem. If a greater than b greater than 0, integral 0 to pi dx by a square plus b square minus 2ab cos x dx is. Actually speaking, nothing new in this problem, but it is a famous answer, famous question and having famous answer, pi by b square minus b square. Yes, to focus on that speciality only I am tackling with this problem. You please observe, it is one of the standard models taking tan x by 2 is equal to t. Yes, let tan x by 2 is equal to t. Half into secant square x by 2 dx is equal to dt. But you see secant square x by 2 is nothing but 1 plus tan square x by 2, that is 1 plus t square. From that you can directly have dx is equal to 2 dt by 1 plus t square. 2 dt by 1 plus t square. We have changed the variable in terms of t. Okay, let us change the limits also. If x is equal to 0, what happens? T is equal to tan 0 by 2 is 0, that is t is equal to 0. And if x is equal to pi, what is going to happen? T is equal to tan pi by 2, that is infinity. Infinity. Good. With these changes, let us see what happens to I. I is equal to integral 0 to infinity. What is dx? 2 dt by 1 plus t square by a square plus b square minus 2ab into, come on, what is cos x? 1 minus tan square x by 2 by 1 plus tan square x by 2, isn't it? We have had a beautiful formula in submultiple angles of trigonometry. So cos x is equal to 1 minus tan square x by 2 by 1 plus tan square x by 2. Basing on that, we will be able to write 1 minus tan square by 1 plus tan square. Good. Multiply with 1 plus t square of both numerator and denominator so that it becomes 0 to infinity 2 dt by a square plus b square into 1 plus t square minus 2ab into 1 minus t square, isn't it? Again, this is equal to integral 0 to infinity 2 dt by, come on friend, take t square out. T square into, here it is a square plus b square and here it is plus 2ab. And then those terms which do not contain t are t square. What are they? A square plus b square minus 2ab. Okay, the things are clearly visible before our eyes. This is nothing but a plus b whole square, and that is nothing but a minus b whole square. Of course, by taking a plus b whole square out, we will be having a standard formula here. Well, so we can still simplify that, and to do that, I need this space. So I like to remove these steps. You please note them down in your mind first of all. Okay, this is therefore equal to 2 into integral 0 to infinity dt by, this is a plus b whole square and that is a minus b whole square. A plus b whole square into t square plus a minus b whole square. That is again 2 by a plus b whole square into integral 0 to infinity dt by t square plus a minus b by a plus b whole square. That is, I have pulled a plus b whole square out as a common factor. And this looks like 1 by x square plus a square, isn't it? What is the formula for the integral of that 1 by x square plus a square? What is it? 1 by a tan inverse x by a. So it is 2 by a plus b whole square into 1 by a, means 1 by a minus b by a plus b into tan inverse t by a minus b by a plus b between the limit 0 to infinity. Good. 1a plus b will be cancelled. A plus b into a minus b is a minus b whole square. Therefore, this is 2 by a plus b into a minus b is a square minus b square into, come on friend, you first of all put infinity. What happens to this? Tan inverse infinity is pi by 2. Then you take t is equal to 0. Tan inverse 0 is 0. Automatically 2 will be cancelled, leaving you pi by a square minus b square. You might have remembered in the very beginning itself, we have noted the answer in our mind. This question has been dealt with. This question has been dealt with by us because of its popularity of the answer. Not only that it is a standard problem, it is more popular also. The standard answer, pi by a square minus b square. To recollect the answer and keep in mind that answer, I have tackled with this question. It's a very beautiful question. Have a note of this. Please observe the question. The next question, the new question before us is integral 0 to 1 by 5 plus 2x minus 2x square into 1 plus e power 2 minus 4x dx. What is that? See, there is a crucial idea in solving this very easily. There has been a beautiful formula for us. Let me recall that formula. Integral 0 to 2a f of x dx is equal to integral 0 to a f of x plus f of 2a minus x dx. Let us make use of that. By using it, in what shape it will occur? Let us see. This is equal to integral 0 to half. Why? Because integral 0 to 2a is going to be termed as integral 0 to a, isn't it? F of x means 1 by 5 plus 2x minus 2x square into 1 plus e power 2 minus 4x plus 1 by, now we are to have f of 2a minus x, isn't it? What is f of 2a minus x? 2a is 1. So we are supposed to replace x by 1 minus x. What happens? Let us see. 5 plus 2 into 1 minus x minus 2 into 1 minus x whole square into 1 plus e power 2 minus 4 into 1 minus x. This entire thing dx. Let us see what is going to happen. Integral 0 to 1 by 2, 1 by 5 plus 2x minus 2x square into 1 plus e power 2 minus 4x plus 1 by, well my dear, let us avoid all the steps of simplification. Let us try to imagine. First of all, constants. How many constants will be there? This is 5. This is 2 ones are 2, 7. And this whole square, 1 will be there. Minus 2 into 1 is minus 2. Minus 2 and plus 2 will go away, leaving you only 5. Good. The coefficient of x. How many x's will be there? Here it is minus 2x, minus 2x. And again, in the expansion of this whole square, you will be having minus 2x. Minus 2 into minus 2x is plus 4x. So minus 2x plus 4x is plus 2x, isn't it? Plus 2x. Next one, x squares. No x square, no x square. Here in this expansion of this whole square, we will be having 1x square. Minus 2 into x square becomes minus 2x square. Fantastic, fantastic. What could you observe? Even if you substitute 1 minus x in the place of x, this expression has not been changed at all. No change at all. Okay, well, what is C? What is C in the neighboring expression? Into 1 plus e power. Come on, first of all, you observe the constants. How many constants will be there? 2. Minus 4 into 1 is minus 4, 2 minus 4 is minus 2, and x is minus 4 into minus 6 is plus 4x dx. Yes. Again, to avoid the steps, you think of the expression more generally. Come on dear, you take 2 minus 4x, some t in your mind, don't put on paper. This is t. Automatically this is minus t. And this expression 1 by 5 plus 2x minus 1 2x square can be got out as a common factor. So that this is integral 0 to half 1 by 5 plus 2x minus 2x square into 1 by 1 plus e power a plus 1 by 1 plus e power minus a dx. You put in your mind only, do not put on paper. I am taking this 2 minus 4x as a. 1 by 1 plus e power a, 1 by 1 plus e power minus a. Isn't it 1? How and why? Multiply this with both numerator and denominator with e power a. What happens? E power a by e power a plus 1. The same denominator, they will be cancelled, leaving you 1. I think you can agree with that. You can agree with that. Yes. Where a is equal to 2 minus 4x. It's very clear, very clear to say that this expression is 1. Therefore, ultimately, what is the definite integral which is before us to be solved? It's one of the more standard problems, 1 by a quadratic, of course. It can be done in 2 ways. Number one perfect squaring way, and another, it can be factorized, isn't it? It can be factorized, of course. In 2 ways it can be done. If you have the factors here, 2x square minus 2x minus 5, oh sorry, no factors. So it can be used, it can be simplified by using perfect squaring method. Yes, we shall be going to do that in the next step. The next one. So this is 1, of course. Therefore, I is equal to integral 0 to half 1 by 5 plus 2x minus 2x square is there. I am pulling 2 out. What is going to happen? 5 by 2 plus x minus x square dx. Again, this is half into integral 0 to half 1 by 5 by 2 minus of x square minus x. To make this a perfect square, what quantity is supposed to be added? Plus 1 by 4, isn't it? Plus 1 by 4 and again plus 1 by 4 dx. Minus 1 by 4 and plus 1 by 4 will go away. And now 5 by 2 plus 1 by 4 is 10 by 4 plus 1 by 4, 11 by 4. Hence, this is half into integral 0 to half 1 by 11 by 4 minus x minus half whole square. X minus half whole square dx. X minus half whole square. Well, my dear, instead of x minus half whole square, I am interested to write half minus x whole square. Both are same, no problem at all in writing x minus half whole square or half minus x whole square. But you see, I am going to have an extra benefit here. Again, we can make use of the formula integral 0 to a f of x dx is integral 0 to a f of a minus x. That is, in the place of x, let me put half minus x. Let me put half minus x. Then this is again equal to half into integral 0 to half 1 by 11 by 4 minus x square. Am I correct? Half minus, in the place of x, I like to put half minus x. Half and half will go away, leaving you x only. So it is 11 by 4 minus x square. Well, my dear, this looks like the standard answer 1 by a square minus x square. You please recollect what is the integral of 1 by a square minus x square dx? 1 by 2a log mod a plus x by a minus x. Right? Shall I write the formula? I think it is not necessary because it is such a standard formula. What is 1 by integral of 1 by a square minus x square? 1 by 2a log mod a plus x by a minus x. Basing on that, you can write this as one by 2 into 1 by 2a. In the place of a square, we have 11 by 4. So in the place of a, we should have root 11 by 2 log mod root 11 by 2 plus x by root 11 by 2 minus x between the limits 0 to half. Good. 1, 2 will be cancelled. 1 by 2 root 11 into log mod. If you take x is equal to half, then root 11 by 2 plus half is root 11 plus 1 by 2. Root 11 minus 1 by 2. If you put x equal to 0, root 11 by 2 by root 11 by 2 becomes 1 and log 1 is 0. Log 1 is 0. So totally it is 1 by 2 root 11 into log mod. You can cancel 2, and if you want to rationalize the denominator, you may have to multiply with root 11 plus 1 so that it becomes root 11 plus 1 whole square by 10, isn't it? Yes, by 10. And the 2 and 2 will go away, so that 1 by root 11 into log mod root 11 plus 1 by 10 is the upcoming answer. If follow that, it's a beautiful problem. Let me call this I. You please look at the problem. If 0 less than b less than a and b are two positive numbers with b less than a, of course, a is the greater number. Integral 0 to 2 pi sine square theta d theta by a minus b cos theta. That is the problem. Well, I is therefore equal to 2 into integral 0 to pi sine square theta d theta by a minus b cos theta. Am I correct? What step I have made use of? Integral 0 to 2a f of x dx is equal to 2 into integral 0 to f of x dx, provided f of 2a minus x is nothing but f of x. Come on, replace theta by 2 pi minus theta. Do you observe any change? No change at all. The same function will going to be obtained again. Sine square of 2 pi minus theta is sine square theta. Cos of 2 pi minus theta is cos theta. Why? Because 2 pi minus theta means it lies in the fourth quadrant, and in the fourth quadrant is supposed to be positive. Okay. That is why I have pulled 2 out. Now this is the right time for us to use the formula again. Integral 0 to 2a f of x dx is equal to integral 0 to a f of x plus f of 2a minus x dx. I think you can recollect that. It is one of the most standard formulae. And in the place of 2a, we have pi here, so that you can write this as 2 into integral 0 to pi by 2 sine square theta d theta by a minus b cos theta plus f of 2a minus x, that is f of pi minus x, sine square theta by a minus b cos pi minus theta d theta. D theta. I think you could have noticed the formula that which I have used here. Okay, 0 to a f of x plus f of 2a minus x. I could have written. Come on friend, this is a minus b cos theta, whereas this is a plus b cos theta. Why? Cos of pi minus theta is nothing but minus cos theta, so that this is equal to 2 into integral 0 to pi by 2. I am getting sine square theta as a common factor. Inside the brackets you will be having a minus b cos theta plus 1 by a plus b cos theta d theta. Am I right? Okay, this is equal to, come on, imagine the expression inside the brackets. A minus b into a plus b cos theta, a minus b cos theta into a plus b cos theta is nothing but a square minus b square cos theta. What happens to the pair of numerator? A plus b cos theta plus a minus b cos theta. B cos theta and b cos theta go away, leaving you only 2a. You pull that 2a out, so that it is 4a into integral 0 to pi by 2 sine square theta by a square minus b square cos square theta d theta, right? Okay, like that we can write it. Next one. There is a chance of getting it simplified. Still, there are so many ways, but dividing with cos square theta and or otherwise, it can be split into two integrals. Let us see. Is equal to 4a into integral 0 to pi by 2 b square into 1 minus cos square theta by a square minus b square cos square theta. Isn't it? And this can again be simplified as 4a by b square into integral 0 to pi by 2 a square minus b square cos square theta minus a square plus b square by a square minus b square cos square theta. I would like to see the entire denominator in the numerator itself. A square minus b square cos square theta. Already minus b square cos square theta is available. Plus b square is okay. Extra item is a square and a square. Cancel that. So that this can be looked as again as it is equal to 4a by b square into integral 0 to pi by 2, this by this 1 minus a square minus b square by a square minus b square into cos square theta d theta. Cos square theta d theta. Now this is the time to convert, take these cos thetas etc. into tan thetas, into it is a square minus b square by a square minus b square cos square theta. A square minus b square cos square theta d theta. Okay, this is of course pi by 2, no problem at all. Integral 0 to 1 of pi by 2 is pi by 2. No problem at all to deal with. This and the second part is only remain here. So this is 4a by b square into pi by 2, 4a by b square into integral 0 to pi by 2, 0 to pi by 2. Come on, I am dividing both numerator and denominator with cos square theta, so that you may be having a square minus b square secant square theta by a square secant square theta minus b square d theta. Of course, in the denominator you have secant square theta is 1 plus tan square theta, no problem. For a pi 2a pi by b square in minus 4a by b square into integral 0 to pi by 2, a square minus b square secant square theta by a square into 1 plus tan square theta, that is a square tan square theta plus a square minus b square. A square minus b square. Altogether this is 2a pi by b square minus 4a by a square b square into a square minus b square into 0 to pi by 2 secant square theta d theta by tan square theta plus a square minus b square by a square. Automatically, if you take tan theta is equal to t, this is nothing but dt, and it takes the form dt by t square plus x, t square plus a square. Answer is 1 by a tan inverse x by a, that is, this is equal to 2a pi by b square minus 4a into a square minus b square by a square b square into, you see, tan inverse 1 by a, that is 1 by root a square minus b square by a into tan inverse of theta by root of a square minus b square by a between the limit 0 to pi by 2. To pi by 2. By getting it simplified, you will be having the answer. Almost all the integral part is over, isn't it? Well, so there ends the matter, and you can easily estimate the answer. The problematic part is now completed. This is simply for the sake of brevity, I am leaving it there itself.